the National Science Foundation and develop manufacturing systems by the Sir, the stage is yours.
All right. Well, thank you everyone for coming. I hope this is actually better to let you go around. Okay. Well, great. So, yeah, I just, honestly, I just got here in Coimbatore. I came in last night. I was in Mumbai, and so I missed the first half of the presentations today. I was just talking a little bit to Ravi, a little bit about his presentation on Industry 4.0, which is a really a major initiative that is really taking off globally on how to some of the issues in really the industrial Internet of Things, and that aspect of the data-centric part of manufacturing is really a major area of research and development that, again, globally, that is revolutionizing the way that we're looking at not only production efficiencies, but that's also coupled with sustainability issues in things like water usage, energy usage, and emissions at the same time. And so in that sense, it's a more holistic view of the entire manufacturing enterprise with this data-centric kind of digitalization approach towards making using sensors and embedded data acquisition or embedded computing technologies to automate the processes of the manufacturing enterprise. And so that's a really important area as the people earlier in looking through the program for today. That really makes an important impact in terms of the students here in particular, in terms of what you can do and directions you can take in terms of your own studies, but also this question of grad school and when to stop your formal education and transition into either industry or academia. And so I wanted to talk a little bit about about IoT, right? The Internet of Things, and what that really represents. Because that has become a really, in some sense, overhyped buzzword. And it's because technically there is something called the Gartner hype cycle, which is kind of a plot of what happens with new technologies. And right now, IoT, the Internet of Things, is kind of at the peak, or is right now at the peak of that Gartner hype cycle, meaning that it's getting a lot of buzz in the mainstream media and press. It's being adopted a lot by companies and academics, such as myself, in terms of describing things. And so it really kind of represents a kaleidoscope of technology, in terms of who you talk to really get a definition of, well, what do we mean by the Internet of Things? And clearly, the Internet aspect, right? So if we break down the words, there are obvious commonalities, right? Because we're talking about the Internet. We're talking about extending networking capabilities to things. And if we think about how that has evolved, right, or how the Internet has evolved, it's really been about individual pieces of data. And what made that is being transformed really by us, humans. And I'm going to talk a little about what some of those implications tomorrow are for how technology has transformed us as human beings, not just in the tools we use, but actually some of the ways we think now. But that's really been what the internet has been, right? Is a relatively, as a communications medium, as a network tool, it's relatively passive. It connects humans, in other words, intelligent agents, right? Because we have plans, we have decision-making capability, and so we use the internet, right, to, through the exchange of data, to get things that we need, right? To get either information, a classic example is mapping, and Uber or some of the ride sharing services, right, is, I think, really interesting. If you look at Uber specifically, if you look at their website and see how they describe themselves, they don't say anywhere they're a ride sharing service. Even though that's the way the media and the discussion of some of these different companies that are providing ride sharing, right, are talking about that all the time. Uber never uses that phrase. Instead, what they say is basically they're changing the way the world moves. And that, I think, is part of this aspect of the internet, right? That you have intelligent agents that are connected together. Well, then what do we mean by a shift to things when we talk about the Internet of Things? Because what humans do when we access this data that we need, for example, a schedule on aircraft or rides, or movie times or meetings, we then process that stuff, that data into manageable information. And the problem is, now if we're going to hook up our kitchen appliances to the internet, if we hook up our office machines to the internet, if we hook up stop traffic lights and signs even to the internet, right? Well, how then are these normally we think of as dumb or passive machines, how are they going to actively communicate the way humans do in a meaningful way and creating that switch, that abstraction from what is just raw data into meaningful information, okay? And so the Internet of Things is really complex and nuanced in terms of what has to happen in order to have machines now start to do that automatically. And in some sense, it's a lot like a big giant nervous system. Much as the human body is distributed to a bunch of communication channels with our nerves and synapses and a bunch of neurons that's doing the computation, still, right, it's the benefit of this idea of the Internet of Things is how to make that whole system end up being more than the sum of its parts. And I think the idea of activities, and that's why, you know, Uber doesn't describe themselves as a ride-sharing service. I think they're starting to talk about how to make activities happen. Much like, right, the internet it was about information, and you can get a map, right, from Google Maps or from MapQuest or from a number of Alibaba maps or whoever, depending on what your local service is that you prefer, right? You can get information that kind of tells you how to get from point A to point B, right? Things like Uber and ride sharing actually move you from A to B. And so what I believe is the essence of the Internet of Things is not so much the sensors that are getting data and bringing it into the cloud. there actually have been websites and apps that have been doing that for as much as 2 decades. Early in the a site called the Weather Underground is a global site that is has a bunch of sensor weather stations that you can get basically community-hosted, crowdsourced weather information. And they were incorporated in the 1990s, 20 years ago, for just that idea of providing sensors that can measure the temperature and the local weather conditions that you can then access globally at any point. Again, that's that kind of one-sided information flow from sensors to the cloud, okay? Uber, right, as just an example, but Uber goes not just from the information of, oh, there are a bunch of drivers out there, there are a bunch of cars, there are a bunch of people who want to get between point A and B, there's some information on maps, actually gets you from A to B, not just tell you how to get there. And activity happens as the result. In other words, there are actuators tied to this system. It's not just data flowing from sensors up until some database, the cloud. But as a result of that, it flows back, right, to actuators, ultimately, that in the case of Uber as a ride-sharing service, right, those actuators partly are people, but they're also cars and things that actually allow you to follow a route from A to B. And this, I think, is a subtle but really important difference in what the Internet of Things will be compared to what the public internet is. And it raises a whole bunch of really exciting and undefined, as yet undefined ideas for research. And the cool thing is, being part of robotics and automation engineering, right, is that's the way we define a robot. It's about sensing, computation, and actuation. And so, effectively, what we're trying to do with IoT technologies is kind of convert really the whole world into a giant, maybe distributed, robotic system. That again takes data in, does some processing and thinking about it, maybe at different levels. We talk about edge computing and cloud computing and things that are happening at different levels as that data flows and becomes information through processing, through analysis, through abstraction into computation, right? And then again flows back out to the physical world. And this is why we refer also to some of these technologies as cyber-physical systems, right? Because there's actually this transition from the physical world that we live in to the cyber world that, of course, our computers operate in. But it's the sensors, and it's the sensors that bring it from the physical world into the cyber world. And likewise, it's actuators that take it back out. And the other way we can think of that is sort of the analog and the digital world, right? So the physical world is where things happen in analog. They get transduced by sensors into the digital world so that we can compute. Pardon me. And so I think that's really, as opposed to wireless sensor networks or sensor networks in general, right, where we've been doing that work of taking sensing in, the Internet of Things is really about closing that loop, getting information back out, affecting the world in sometimes slow control loops, feedback control loops, but sometimes very fast. And that also brings up a couple issues in opportunities, and like what's being referred to as cloud robotics. How, this is a new research area that is closely related again to the Internet of Things, is what can we do in closing those loops from sensing through computation and decisions back into actuation when we have so much compute power available in the cloud. Because the cloud now has morphed into not just a big data database or data repository, but services that provide for computation and lots and lots of computation that can be, again, scattered, that is scattered throughout this network. So some of the computation might be very close to the sensors. It might provide some data abstraction. It might provide some compression. But there's also distribution that can go out to different users. And at the same time, all that, right, is there's huge opportunities in data science and feeding, right, some of the basic information in terms of the complexities of the world that we can look at. And of course, when you start to talk about this as research opportunities, that there are so many, as I mentioned, you know, that IoT is being used to not just, or Industry 4.0 and its connection to IoT, is not being used in the manufacturing environment just to focus on productivity and, for example, profitability, right? The companies and users of these IoT services and Industry 4.0 services are looking a lot more at these holistic questions, as I mentioned, of what about the general sustainability of the planet? What about the sustainability of society in general and individual societies, right? Because we are still a very diverse global community. But getting closer and closer at the same time. And so I think this collection of application areas that we can now address through IoT type technologies, where we have this ability to bring in data from all kinds of things, all kinds of areas of our lives, and use it through different decision-making processes, right? To be able to use it for all kinds of, let's say, all kinds of beneficial results. Which then also brings up a whole nother aspect of research that we have to be concerned with was okay, if we, as everyone in this room with nice benevolent intentions, can do wonderful, amazing things with the data we have and the networks we have based on this IoT kind of infrastructure, turning the whole world effectively into a giant robotic entity in some sense. That also means, of course, that someone with malicious intent can do the same thing, right? Use that same network, that same information, that same reduction, abstraction of data to information, right, for malicious purposes. And that means security, privacy is a whole exploding areas of both research and implementation, again, for future research and future careers, right, of how do we maintain, right, appropriate control and use as in a distributed and decentralized manner. And so all these, I think, are really rich areas of study. I think this is largely what the ICARS conference is about, is looking at smaller pieces of these. And I'm going to, again, talk about it in a couple of talks later, of different pieces of these puzzles with more detail. But the bottom line is, I think this is a really exciting area. I think there is a wonderful group of a collection of people that are going to be talking about this from again, a whole different, a variety, I should say, of perspectives. And that's one of the things that I find exciting in my career, is I'm collaborating now with such a much more diverse group of fellow researchers. Not just engineers and computer scientists, which is really where my PhD started, almost 30 years ago, but psychologists and social scientists and agricultural experts and climate experts and water and soil people that really we're getting to a really exciting time, I think, and we continue to get into this exciting age when there's the opportunities, I think, for doing really exciting work is beyond what many of us imagined 30 or 40 years ago. So I'm going to stop there before I'll just keep wandering on, and thank you for your attention. Okay. Anyone have any questions? Happy to take a few. No takers. All right. Okay, well, thank you.
Thank you, sir. Thank you for such an inspirational speech on IoT. Sure, I guess everyone could have followed it. Now I request Dr. B. Vinod to present Richard Voyles, sir, with a token of gratitude.
Registered as a participant for the workshop. We will have a demonstration of the robotic welding facility. So kindly accompany the faculty in charge of that. And with that, we'll end this pre-conference workshop. So on behalf of the Department of Robotics and Automation Engineering, I thank you all for attending this pre-conference workshop. And tomorrow and after tomorrow, 2 days of a lot of discussions, debates happening in the areas of robotics, Industry 4.0. So I request all of you to attend that, enrich yourself and experience this field of being in a robotic society. Thank you. Thank you, wonderful.